How's it going, guys? It's Jiggy here, and in this video we're going to be taking a look at something called functional application. We're going to be taking a look at how functions are applied to the parameters that we supply to it, and we'll also be taking a look at how a function is actually evaluated in a functional programming language as well, and this is going to help make other things a bit more clearer. So let's get started. As you can recall, there are three main parts of a function. We have the function itself, which is going to map an argument from the domain to a value in the codomain. Now let's take a deeper look into the mapping of an argument from the domain to a result in the codomain. First of all, let's define what functional application is. Simply put, it's the process of providing an input to a function. That's it. We will need to understand how this actually works in a functional programming language though, and how functions are actually going to be evaluated. Let's have a function called add these three integers, which is simply going to take in three integer arguments and add them together. Suppose we were to supply this function with arguments 2, 4, and 5. Now, before we move on, we have something key to remember. Even though we pass in three arguments, functions in fact can only accept one argument at a time. Keep this in mind as we go through this video. Okay, cool. You might be thinking, hang on, you're saying that even though I can pass through three arguments, a function can only accept one? Well then how does the function actually handle them? Let's make this clearer and go through the evaluation pipeline. The first thing a function does is it considers the first argument, which is 2. What then happens is, your functional programming language is actually quite clever. Under the hood, it's going to produce a new function based off the first argument in order for it to fit in with the rule of functions only being able to accept one argument. This new function will add 2 to the remaining arguments, so for the sake of understanding this evaluation process, we're going to call this function add2. This means that add 3 integers with parameters 2, 4, and 5 is also the same as having a function called add2 with parameters 4 and 5, and it's going to do exactly the same thing. Okay, great. Add 3 integers has been broken down into add 2 with parameters 4 and 5. But we still have 2 parameters, right? And functions can only accept one of them at a time. So that add 2 function with parameters 4 and 5 needs to be broken down once more. What happens is add 2 will only be applied to the first parameter, which is 4. So what happens to the 5 then? That still needs to be added on, right? Since 5 still needs to be added, what will happen is the 5 will be evaluated to its own function called add5. This is going to be taking in the result of 4 being supplied to add 2, and we're going to end up with this sort of pipeline. Now let's apply the function. Add2 with argument 4 is going to produce 6. This 6 will then be the argument for add5. Add5 with argument 6 is going to give us our output of 11. Now you can see that the add 3 integers function with parameters 2, 4, and 5 obeys the rule of having one argument only by first breaking it down into add 2 with 4. The final parameter, which is 5, is then broken down into its own function called add5, which will then, of course, add 5 to the result of add 2, 4. You can see how each function only has one parameter now, which fits into our rule that we talked about earlier, and this is how functions are evaluated in a functional programming language. For our A-level, we're going to need to know how to express functional application mathematically. The type of function for add these 3 integers with parameters a, b, and c is going to be f is a function which maps an integer, cross integer, cross integer, which then maps to another integer. Let's explain this a little bit more. Integer, cross integer, cross integer are the arguments, which are the parameters for this function. In this notation, the crosses represent the Cartesian product of the argument type. If we remember our set theory, we'll know that the Cartesian product is the overlap. And since all these 3 parameters are integers, the overlap will of course also be an integer. And finally, the arrow integer part is what the function maps to, which is of course going to be the result of the function. And we're done. Let's have a quick recap. We know that the definition of functional application is the process of providing arguments to a function. We learned that the functions can only accept one argument at a time, and we learned how functions are evaluated in a functional programming language, as well as a mathematical notation for it.